My name is Konstnatin. It is line detection using Fourier-based line detector. Problem setup is detection of the road lane boundaries via usual camera perspective model. My motivation is Fourier transform is one of the equations that change the world. It can be useful for us because it helps for a lot of engineers, and also engineers from medical imaging use Radon transform to solve very interesting problems. And from computer vision problem point of view, Radon transform can be observed that it in some sense similar to Hough transform, but it's not the same. Parents of this work for edge detection use scanning edge detector, and then you use standard Hough transform. In the presented work, we don't need it. First step is select region of interest. The second one is we average several frames and do this blurring to connect previously unconnected line markers. In perspective model, the parallel lines are intersected in vanishing points. We don't want it really because we want to leverage on it property to save this property that parallel lines are parallel. And to do it, we do some unperspective mapping and then change our point of view to a burst point of view and do orthogonal projection. But to do unperspective mapping, we need some assumption. We use assumptions that the road is now assumed to be flat in the region of interest. It looks like this. Radon transform is you give me a line and I evaluate integral over the line of some predefined function. Radon transform has deep interconnection with Fourier transform. Standard Radon transform looks like a synonym from Hough voting, but it's not a Hough voting. For Hough transform, input is binary image. For Radon transform, input is intensity image with real values. In Radon transform, we evaluate integral over the function of a line. In Hough voting, we vote, so schemas are different. In this work, we introduce I use so we're working in a generalization of discrete Fourier transform. Original discrete Fourier transform is defined with a function which was defined in some integer points. So it's just a finite collection of samples. And via fractional Fourier transform, we can work with a discrete Fourier transform, but with which has values in a fractional points. Multilayer means that we want to incorporate different grids simultaneously. After receiving a great version of Radon transform, we can find peaks. Then after recommend to do something like this: pass the green lines, find intersection, and then find intersection, and with this intersection use ransack to eliminate noise and outliers. I carried some experiments based on dataset provided from Kitty. All pipeline, including all math transformation, have been implemented by me. Conclusion: I think humans can compete with neural networks only via finding interesting things in functional analysis, where the dimensional of space is very high, and it opens the doors to concepts understandable for humans. We can understand the limitation processes, integration, but really computer don't know what is it. I hope to port this work to C++. So it's all. Thanks. Oh, it's time. Okay, so also during reading reference, I have seen that Fourier-based method can also be used for finding shift, rotate, and scaling invariant features. So not only the shift, but it exists papers when people use Fourier transform to find such features. So thank you. Bye.